You're listening to Worth Electronics What's Up radio podcast, where each week we are seeing what's up in the world of electronics and PCB design. We'll be checking in with leading industry experts and Worth Electronic technical specialists. We're going to shine a light on our topics such as energy harvesting, wireless power transfer, EMI issues, and so much more. Tune in to get technical design tips and applications during your commute, at your desk, or wherever you might be with Worth Electronics What's Up podcast. The autumn season is here and the temperatures are cooling off, but that doesn't mean that your electronics and your applications are doing the same. There are certain steps that need to be taken in order to dissipate heat, and today we are going to discuss those thermal interface materials. We'll begin by giving a brief overview of what heat energy is, and then cover how it affects electronics designs and how we can manage it with different materials and strategies. First, the basics. The first law of thermodynamics states that energy cannot be created or destroyed. Alternatively, it is a statement that energy can be transferred between a system and its surroundings through the transfer of heat or the performance of mechanical work. The first part is what applies to our designs, how to make sure heat has a path to follow from the source to the sink. This can be done via conduction, convection, and radiation, but today we will focus on conduction. As of now, thermal management is a very big issue. This is because of the miniaturization of designs, components, and the increase in power density. Temperature-related failures account for more than half of our problems in electronics devices. A good thermal management of your designs will ensure longer component and device lifetime. Thermal interface materials are what makes sure that the thermal transfer between the heat source and the cooling assembly is as efficient as possible. Even though the contact surfaces of the heat source and the cooling assembly seem flat and coplanar, microscopic irregularities have a huge toll on the thermal performance of the system. Thermal interface materials make sure that there are no gaps between the heat source and the cooling assembly, and they provide a low thermal resistance path for heat to flow through. These materials can be divided into two groups. Gap fillers are great to provide an interface between a source and a cooler, and then heat spreaders transport heat in a horizontal plane and it distributes it along a surface. The bigger the surface spread, the more energy transfer to the ambient. So this is particularly relevant when working with enclosures. Worth Electronics WE-TGF is a silicone-based elastomeric gap filler, and this is one of the most popular gap filling solutions because of its wide range of thicknesses and its performance. The gap pad is tacky by nature, so it's going to stay in place during assembly until the final compression. Optimal performance is reached when the pad is compressed between 10 and 30% of its thickness. The WE-TGF thermal insulation pad is great for applications where a thin interface is needed and it needs to withstand high compression forces. Next, we have Worth Electronics WE-PCM. This is a paraffin-based phase-changing material. It's going to remain solid at room temperature, and then it will enter a flow state once a temperature over 60 degrees Celsius is reached. Since it can be pre-applied to cooling assemblies, it's easier to handle in production environments than other liquid thermal interface materials. By filling even the most microscopic gaps and its thin bond line, it provides the lowest thermal resistance in the portfolio. If you have ever visited the Worth Electronic thermal management portion of the website, you may have noticed the newest WE-TTT. This is a thermally conductive double-sided adhesive tape, and thanks to its pressure-sensitive adhesive, it's able to hold in place cooling assemblies without the need of mechanical fixing with screws or even clips. The WE-TGS is from the second group that we discussed at the beginning, which is the heat spreaders. So this group of materials have a high thermal conductivity in the horizontal plane. This helps heat to distribute itself over a greater surface. Thanks to its flexibility, the TGS can be applied to surfaces with edges without affecting its spreading performance. It can be combined with gap-filling solutions to further extend its applications. And finally, we have the WE TGFG. This is a hybrid gap-filling and heat-spreading solution. By wrapping a graphite sheet around a foam core, we're able to turn a heat spreader into a gap filler, bringing both types of thermal interface materials into one simple solution. Unlike traditional gap fillers, the WE TGFG can be manufactured up on demand with different profiles to fill gaps between irregular surfaces. With Würth Electronics thermal interface material, designers have a one-stop shop for all their thermal needs. Keep an eye out for the design guidelines of each product family, where the designer can find specific parameters of the thermal interface solution that they might be interested in, handling recommendations, and also frequently asked questions. One thing that needs to be remembered is that thermal interface materials come in many shapes and colors, so it could be difficult to choose the right one for your design. Each solution is not specific to a particular field, such as power electronics, embedded systems, and so on. It is your design that will point you in the right direction. The design-in process begins with an analytical approach. Using the electrical thermal analogy, you can actually estimate if the solution you picked initially is the right one for your design. This tool is great as an estimation tool. It will point you in the right direction, but it's not a design tool. For that, we have FEM simulators, which are able to compute complex systems and evaluate our designs. To help the designer, Würth Electronic has ANSYS models of our solutions available. Prototyping and experimentation is going to confirm your design, and it can still leave room to test different solutions. So in summary, current electronic design trends make thermal management a bit of a challenge, but luckily there are many solutions available to the designer. As a general recommendation, the best performing thermal interface is the one where the bond line is the thinnest. Being a gap to fill, heat to spread, or a combination of both, Würth Electronic is your one-stop shop. To view all thermal management products from Würth Electronic, visit www.we-online.com. You're listening to Würth Electronics What's Up radio podcast, where each week we are seeing what's up in the world of electronics and PCB design. We'll be checking in with leading industry experts and our very own Würth Electronic technical specialists who will shine a light on our topics, such as energy harvesting, wireless power transfer, EMI issues, and so much more. Tune in to get technical design tips and applications during your commute, at your desk, or wherever you might be with Würth Electronics What's Up podcast.